And then we can start to think about some shifts, horizontal shifts. So we take our graph where it is and slide it to the left or to the right, and we haven't changed the shape of our graph at all. We're just sliding it one direction or the other. That's a horizontal shift. And the way it looks is that we have this function of x, and inside with the x, we're adding a c or we're subtracting a c. C is how many units, and if we go plus c, it's going to be left. Seems the opposite of what you would think. Left 2 units, and then minus c will be right 2 units. So you always are going to think about swapping. If it's on the x's that the change is happening, you'll think about just swapping the right for left or the direction if you are trying to figure it out. Here is stretch or compress, and that is if it's done inside with the x here. You can see it's happening inside. That would be like inside the absolute value or inside a squared or something like that. That we are going to be doing some horizontal stretching if the c is a fraction, and if the c is greater than 1, we'll do horizontal compressing. And you can see how we've laid out each of the transformations that you're going to encounter. But I think I'd like to jump down here to filling in this table. If we have a function, and inside the function notation with the x, we are doing a plus 1, that is going to move us left 1, and the way we figure that is because it's a plus c, and the c is how far we're going left because of the plus. So that's how I know that, and it's inside with the x. So if you have a squared graph, like a function that's x squared, that's going to look something like that. It's a parabola. And if you have a plus c happening to it, it's going to look like x plus 1 quantity squared. Okay, let's look at an absolute value graph. So absolute value graphs look like this, straight edges. And if we have this plus c thing or the plus 1 going on, it's going to be inside the absolute value part with the x. It'll look something like that. And then for a cubic, that's going to have this shape. Remember, you should kind of know these shapes. I would memorize them if you don't already know them. And we're taking a plus 1 in with the x, so it's going to be x plus 1 quantity cubed. And that's how we know that it's going to be a horizontal shift, because we're inside the quantities with the x. For this last one, this is the square root of x, and it has this shape. And for our plus 1, it's going to be the square root of x plus 1, all underneath the square root together. So I'm hoping you can start to see how these shapes, these transformations look for our 4 parent functions in this case. And I'm going to show you a couple more. So if we do f of x minus 2, and the minus 2 is inside with the x, it means we are going right 2 units. So right from the negative and 2 units from the 2, obviously. And we know it's shifting left or right because it's inside with the x. So that looks like x minus 2 quantity squared for a parabola, absolute value of x minus 2 for absolute value, x minus 2 quantity cubed for a cubic, and x minus 2 underneath the square root for a square root graph. All right, I'm going to change pen colors because this is kind of a different category that we're coming up on next. This is negative f of x, so it's the opposite of f of x. It's outside, oopsie. It's outside the function, whereas the next one is inside with the x. So if it's outside the function, it's happening to the y's. So we're going to flip the y's over the x-axis. That's the second part of it that I often leave off just to make it quick. It looks like negative x squared. It looks like negative absolute value of x, negative x cubed, negative square root of x. Okay, the negative is outside the function itself, or the parent part of the function. On this one, f of negative x, now it's inside the function with the x's. Do you see that? So it's flipping the x's over the y-axis. So flip the x's, and the way that would look is negative x quantity squared, which you know will come to a positive x squared, right? And then we have inside with the x's, negative x inside the absolute value bars, and then we have negative x quantity cubed for the cubic and the square root of negative x. So that one, if we want to keep it in the set of real numbers, the x's that we use will have to be negative so that they will undo that negative. All right, shifting colors one more time. When I look at these last two, they are of a category. I have a f of x, and then I'm either adding or subtracting a number to that entire function. It's outside the function, so I know it's happening to the y's, not to the x's. And so I know that I'm going on this one, it goes in the same direction for the y's as it seems. So plus 3 means up 3, and in this case a minus 1 means down 1. And so if I come back and look at my functions, this one, do you see how the x plus 1, it's inside the function, and here it's a plus 3, but it's outside the function? That's how you tell whether it's happening to the y's or happening to the x's. When it's outside the function itself, or the parent part of the function, then it's happening to the y's, so we're going up 3. And this one is down 1 because it's happening to the y's. The y's are the things that make you go up or down as you're graphing. Okay, so for an x squared graph, it's going to look like x squared, and then outside of the x squared plus 3. Absolute value of x outside plus 3. X cubed outside plus 3. And finally, square root of x outside, do a plus 3. Same, it's going to look very similar for the downs. So I'm going to have x squared minus 1. It's outside of the parent function part. Absolute value of x minus 1. X cubed minus 1. And finally, it's square root of x minus 1. All right, so these first two columns, those are horizontal transformations. The second two are reflections, and the third pair are vertical shifts or transformations. And so we showed all of them on this chart except for the stretch and compress, and that's because we don't use the stretch and compress very often. But we also have a mnemonic to help you remember what order to perform these transformations in. And if you do them in the order that we showed here on this table, your graph will come out correctly. And so of course we want that. And you can remember this by Hank sipped red V8. So HSRV. So that helps you get the order right. Horizontal shifts, stretch, compress, that's HS. R for reflections, and V for vertical shifts. So HSRV. And that'll help you get the order correct. And if you write out your transformations in order every time and apply them in that order, your graphs will be accurate every time.